Hello everyone, myself Abhishek Kumar Rai. Today I will be presenting on electromagnetic induction, one of the most important concepts in physics. We will explore how changing magnetic field creates electricity, the laws behind it, and a real world application like generators and transformers. Here, electromagnetic induction simply means creating electricity from magnetism. This revolutionary discovery was made by Michael Faraday, and today it forms the basics for how electricity is produced in power plant and used in a device like a generator and transformers. Before understanding induction, we must understand magnetic flux. Magnetic flux represents how much magnetic field passes through an area. If the field becomes stronger, the area increases or the angle changes, the flux changes. And this change is key to induction. Its unit is a Weber and it depends on several things like strength of magnetic field, area and angle between field and surface. In this slide, we will going to discuss about how EMF is induced. Faraday's laws tell us that voltage is created only when magnetic flux changes. Faster the change, larger the voltage. So mathematically, EMF is equal to minus d phi by dt. Basically, it is the rate of a change of a magnetic flux. It explains the magnitude of induced voltage. And this mathematical formula or equation works for both straight wire and coils. In this slide, we are going to discuss about Lenz's law, which is a very important law to understand electromagnetic induction. Lenz's law explains the direction of induced current. It says that the induced current always opposes the change in a magnetic flux. This is why Faraday's law has a negative sign. This opposition is necessary to follow the principle of energy conservation. It ensures that we cannot get electricity for free. Some work must always be done. A simple example is moving a magnet inside a coil. As you push or pull the magnet, the coil creates a magnetic field that resists your movement, which is why you feel a little force against you. Lenz's law is a very useful in a real world application like induction cooking, magnetic braking in a trains, metal detectors and various damping systems. In previous slide we have discussed that to induce EMF there must be a flux change. Now the question is how flux can be changed. Flux can be changed by various methods like moving magnets towards or away from the coil, moving coil into or out of a magnetic field, changing magnetic field strength, rotating coil, changing area of the coil, and these are the methods to change the flux which induce the EMF, and every practical electrical devices use some combination of these methods. In this slide, we are going to discuss about coil. When a coil rotates, different parts of a coil experience different flux. This causes the EMF to rise and fall in a sine wave pattern. That's why power produced in homes is alternating currents. And now we are going to discuss about the maximum and a minimum EMF. Here minimum EMF is a zero EMF. So maximum EMF at a 90 degree and 270 degree and zero EMF at a 0 degree and 180 degree. Now we are going to discuss about ED currents. So basically ED currents is induced current that circulate within solid conductor. It produced when the magnetic field change in metals. These swirling currents are always harmful, always they cause energy loss and they are exploited to heat metals in induction cookers. But ED currents are also useful in many aspects like induction stoves, magnetic brakes in a train, metal detections, testing for cracks and many more. In this slide we are going to discuss about application of electromagnetic induction. Here we can see the generator, transformer, induction motor, wireless charging, induction heating and many more electronic devices has application of electromagnetic induction. Almost every electrical device around us work on this principle, from the electricity that powers your home to the charger that charge your phone. Induction is everywhere. Now moving to the last section of the video, summary section. We have discussed about many topics of the electromagnetic inductions. like how EMF generated by changing magnetic flux, Faraday laws that provide magnitude, Lenz law that give directions, and many more concepts like flux, EMF, motion, angle, and strength. In short, induction is the bridge between magnetism and electricity. Understanding it helps us understand